Hi, welcome to the class. Today we'll discuss about the further discussion of Bohr's postulate. We had already discussed about the expression for radius, which was r is equals to n square h square epsilon naught 8 z square. And here we understood that this Rn is directly proportional to n square. Now similarly we can do it for the velocity also. So how do we do that? For velocity, angular momentum, which is mvr, is equals to integral multiple of h upon h upon 2 pi. From here you can take out the value of r, or you can use the value of r here and put it in this equation. So mv, instead of r, what you will write? N square h square epsilon naught pi m z square is equals to nh upon 2 pi. M goes off, pi goes off. So velocity will be equal to z square upon n 2 nh epsilon naught. So this is the expression for velocity. Now coming to the energy of the electrons moving in the orbit. If you remember this equation I told you earlier, at mv square you should remember z square 4 pi epsilon naught r. We had done this previously. You can check the previous video also. So now if I multiply it by half, this will become kinetic energy. So half 4 into 2 8 pi epsilon naught. Now for potential energy, earlier also we did this expression that V is equals to W by Q. Potential is equals to work done per unit charge. So work done is equals to potential into Q. Whose potential we are talking about? We are talking about the potential of the nucleus. So nucleus potential due to a single charge. Since nucleus we are treating it to be a single positive charge, it will be 1 upon 4 pi epsilon naught Q upon R. So 1 upon 4 pi epsilon naught. Z is the charge of electron. Why it is there Z? That also I told you. Z is the atomic number. E is the charge of an electron, which will be equal to the charge of proton. And then minus E. Minus E is the charge of electron. So it will become U is equals to, this work done will become potential energy minus Z square upon 4 pi epsilon naught R. So this becomes your potential energy, kinetic energy. Now the total energy will be kinetic plus potential. So we put these values and after putting them together, so plus minus Z square so energy LCM you will take Z square minus 2 Now look at this expression and this expression and try to build up a relation between them. So what could be the relation? If I multiply this by negative, if I multiply it by minus, what it will become? It will become this only. So it means total energy is equals to minus K. I can write it because if I multiply it with minus, it will become total energy, right? Also, look at this and this, they are the same except that this is 8 there. So So if I multiply it by 1 by 2, or if I divide it by 2, this, it will become that. And if I multiply it by 2. So if u by 2 I do, it will become e. It means u is equals to 2e. Right? So remember these two relations, and I am going to tell you one question based on this, because questions also comes of this sort from the exam. So total energy is given. Total energy is given minus 13.6 eV. I'll tell you from where we get this number. Actually the remaining part is left, but I thought let us do this numerical. And you have to find out the total energy, kinetic energy and potential energy. They will ask you like this. They will give the total energy and they will ask you to calculate kinetic energy and potential energy. Now try to do it yourself. So kinetic energy will be minus E using this. So kinetic energy will be 13.6 eV. And potential energy will be 2E multiplied by 2, it will be 27.2 eV. So this is how you have to do these kind of questions. Now moving ahead, this energy is equals to minus Ze square 4 pi 8 pi epsilon naught r. If I put the value of r there, r so now you could cancel this. This will go there. Minus z square e to the power 4 8 epsilon naught square. Kindly check if I am doing it. M will also go there actually. So this is the final expression for the energy, and from here I see that energy is inversely proportional to n square. This is again important, like we did that relation part. This is also important for energy. Total energy is inversely proportional to 1 upon n square, right? Now I will tell you the question from this also. Also guys, if you put the value of Z is equals to 1 for hydrogen, for H atom, hydrogen atom, and put all the values of, and using n is equals to 1, which is the ground state, and put all the values there, the energy of the hydrogen atom at this particular thing will be minus 13.6 eV, the number which you just saw. So energy of the electron in the ground state of hydrogen atom is minus 13.6 eV, right? Now if I put Z is equals to 1 and let it be n square, I keep it like that only. So you know that rest of the things will become minus 13.6, and then my energy will be En is equals to minus 13.6 upon n square, and this is an important relation, EV. 1 E is inversely proportional to n square, second is this. one question we'll do. Question is the energy of an electron in the first orbit of an atom. So one atom is given, we do not know which atom is this. So energy in the first orbit is given minus 27.2 eV. You can calculate the kinetic energy and potential energy for the same using the relation that can be done. What will be the energy in the third orbit? So third orbit means n is equals to 3. So what you do, simply use this relation and E3 will be nothing but minus 13 using this relation. Energy in the third orbit you have to calculate and total energy is given. So this will be minus 27.2 upon 3 square. So that can be calculated using this, right? And if you want to use this, the other relation, this only, what you could do, E1 is equals to minus 13.6 upon 1 square. First, this is given. Okay. This is given, right? First orbit is already given, guys. So this is not 13.6 for this particular atom. This is for hydrogen atoms. So we will modify this relation to be n square eV. So this you can calculate. So it will be minus 3.02 eV. These two were for the energy, and in the next class we will do origin of spectral lines, right? Thank you.